My name is Ismael. I am the founder of Lagrange Labs. So I know it's been a long week, and many of you have probably heard talks about ZK today at ZK Hub and at the main event throughout the week. But what I want to do is take a moment and look forward and look at where ZK is going as a technology and as a space. There's something I like to say. I say it on Twitter all the time, and I say it to my friends and those who talk to me around these events. And that is that ZK is a rare technology, and a rare technology that is unquestionably, unambiguously correct directionally. There's very few technologies that embody this, right? You can say AI, quantum computers, asteroid mining, and ZK are things that I can look at today and say that R&D put into this technology will be beneficial 5, 10, 20 years down the line. There's a future where every computation, irrespective of its use, that secures economic value will be proven with zero knowledge. Everything from the AI models running in the cloud, automating business processes, to the consensus of blockchains, handling the transfer of funds. And so Lagrange is a universal protocol, a universal substrate to support zero-knowledge proof generation, agnostic of use case, across all of crypto and spanning even into Web 2 and traditional sectors. So Lagrange offers a very unique advantage, and that is it is the most performant, most widely used decentralized prover network in the space. It is unparalleled in its scale. It is unparalleled in the performance of its cost structure and the liveness guarantees that it can offer. We work with top protocols spanning all the way from top rollup teams who you've seen earlier here today, people like ZK Sync, Polygon, etc., all the way to top RAS platforms, people like Caldera, AltLayer, and to DeFi and NFT projects. Irrespective of use case, irrespective of demand source, Lagrange services it with decentralized proof generation on our network and with many of our owned in-house products, things like our ZK coprocessor and some interesting work with AIX crypto. Now, what is decentralized proving and why does this matter, right? I think a lot of people like to get on stage and say, okay, well, liveness guarantees, censorship resistance, all this wonderful stuff, but they never explain why any of this is important. Well, if we talk about a future where every computation is proven, it matters that that computation is delivered on time and is delivered as requested. If your DeFi app needs a coprocessor to price collateral as part of a loan, and it can't update that price, the DeFi app is subject to risk and can be rugged. If your rollup can't progress its state transition function and thereby enable bridge withdrawals because no validity proof is being delivered on time, that materially degrades end user experience and compromises the broader security of that rollup ecosystem. That is why decentralized proof generation matters. From a visceral standpoint, a blockchain cannot function without both safety and liveness. A proof can guarantee safety. A proof market, a proof network guarantees liveness. And that's where Lagrange comes in. We are the only production-ready prover network in the space, run by top operators, Coinbase, Kraken, OKX, and more. We support decentralized proving for a broad variety of existing proving systems, things all the way ranging from Plonky 3 to Boojum 2, all the way to our coprocessor and ZKML stuff. And we're some of the most performant provers in the space as well. We have a very unique architecture that we call modular subnetworks that allows us to horizontally scale proof generation in ways that other markets and other networks cannot. How does our network work? Well, you can think of it as an individual market that powers generation for proofs of a specific domain. So when a user wants a proof, or an application wants a proof, and I say user very broadly, a user can be a DeFi app, it can be anything ranging all the way to a ZK Sync Elastic chain, to a Polygon or Maze chain. When someone wants a proof, our network receives a request. Our network then puts that request into a queue in the gateway and runs a double auction. What's a double auction? Think of it like an order book, right? You have bidders express price preferences over the proof generation they require, and sellers express price preferences over the amount they want to spend on compute. Our network has a novel composition rule in which we're able to match bidders and sellers based on these price preferences, and then we're able to have a prover generate this proof with a guarantee of liveness backed by stake. If they don't have a stake and they don't generate that proof on time, they face an economic penalty in the form of a slashing or a non-payment. If they generate the proof correctly and on time, they receive a reward. And this is how we're able to guarantee that irrespective of use case, if you need a proof for a critical protocol function, you can get that from Lagrange. So why do we take a modular architecture to our proving? Well, very simply put, we need to scale horizontally. I think we often can't conceptualize the amount of verifiable computation that can be required in the future. For instance, if we talk about machine learning, AI, autonomous systems, we talk about a roll-up-centric future with tens of thousands of roll-ups, we talk about the beam chain and other high-throughput L1s that are going to require proof generation. You can't have just a single auction running for literally everything, right? It would be bloated. It would be non-performant. So Lagrange says, well, instead of that, instead of just having one giant monolithic construction trying to match bidders and sellers of compute, let's break it up. Let's have independent submarkets specialized in different forms of proof generation for things like roll-ups, for things like our coprocessor, for things like our work with NFT protocols, for things even in AI. And each of these submarkets is able to independently conduct auctions, match bidders and sellers, and then route those resulting proofs exactly where they're needed. It allows us to remain decentralized, performant, and highly scalable. And we talk a lot about matching. What does it mean to match a bidder who wants to generate a proof with a seller of computation? Well, you need a mechanism that is incentive compatible, censorship resistant, and performant. This is where Lagrange's DARA work comes in. DARA is a unique mechanism designed by our team that was actually accepted into a top conference in cryptography and financial engineering called FC, Financial Crypto 2025. And so what DARA effectively does is allow us to compose across a very large set of incoming demand and a very large supply base of provers. And it allows us to do so while enforcing specific properties on top of proof generation. Properties like collusion resistance, like budget balancing, computational efficiency, welfare maximization, all of the types of things that you need in order to generate proofs within your domain with cost and liveness guarantees as are required. And the great part about this work is that this is actually published academic work that you can go read today. It's accepted in the top conferences, and we believe this is really reflective of the type of work a prover network or prover market has to do. And so Lagrange supports universal proving through our modular architecture across a wide variety of domains. We support things like Plonky 3, Plonky 2, and all the dependent VMs on there. You can think of all the major ZK VMs that I'm not going to list out here, but every single one sits on Plonky 3 right now. We support proof generation for our rollups, for coprocessors, for interoperability applications. We have great work that we've announced with teams like Layer 0 and Axler in the interop space. We've announced stuff with ZK Sync and Polygon in the rollup space. And we announced stuff with some of the top DeFi protocols and NFT projects with our coprocessor. Really, we are a protocol that specializes in a wide variety of proof generation delivery across the space. And so let's dive into a case study. So we recently announced some fantastic work with ZK Sync, one of the largest ZK rollup ecosystems in the space. And what we did was we took their Bujum prover, used for ZK Sync Era, their flagship chain, and we deployed this on the testnet in a decentralized fashion. And we demonstrated indelibly that it's possible to generate a proof in a decentralized way with comparable cost and performance to a centralized alternative. Thanks to some of the best operators in the space who run our technology, in this case it was P2P, Nethermind, Black Sand, and Eigenyields, They spun up the relevant GPUs. We developed a market. They participated in that market, and they were able to generate proofs continuously for live batches coming from ZK Sync era. We announced this with the ZK Sync team, and they were tremendous in their support of Lagrange for that purpose. And this was the industry's first example of this, and the first example of actually a decentralized prover network doing work with a major rollup ecosystem. And now, so what's next for Lagrange? And what's kind of the point of all of this stuff that we're talking about? Well, I started this conversation and this talk by saying that in the future, everything will be proven in ZK. Every computation that transacts economic value based on it will have a proof associated with it. The cost of compute and the cost of proving compute is dropping asymptotically, and we will reach a point where it becomes feasible to prove anything. And we believe that everything will be proven on top of Lagrange. So we have some great work rolling out with ZK Sync very soon with our testnet that we will be transitioning into a mainnet alongside some of our top RAS partners, people like AltLayer and Caldera. And we'll be extending out our prover network to support a bunch of work, including ZKX AI. So why is it important to prove AI, and why is this the new frontier for verifiable compute? Well, the value that is transacted on top of inference is only increasing. We talk about the market size for inference as effectively the GDP for knowledge work in humanity, right? All the way from a doctor to a lawyer to, the person teaching your kids. Anything that is knowledge work has the potential to be augmented or replaced by machine intelligence. And the economic value that sits on top of that is near immeasurable. Right? An estimate could put that at about $100 trillion a year as the human GDP for knowledge work. And yet, the guarantees we have of the correctness of this inference are near zero, right? You don't even know if the model you're interacting with from OpenAI is the one they tell you. I mean, likely it is, but there's no way to know for certain. And this is where verifiability becomes so important. All the way from DeFi apps that want to transact and send money and augment positions and rearrange positions based on ML output, all the way through to autonomous defense in aerospace used for government applications. The future of AI requires verifiability, and Lagrange is very excited to announce some work in the coming weeks related to this. And so what I just want to end with one more time is that Lagrange is a protocol to prove everything. All the way from top rollups that operate in crypto today to this futuristic vision of AI being verifiable, aligned, trustworthy, and attributable back to humanity. All the way to fun things like DeFi and NFTs. All of that sits or will sit on top of Lagrange and will be proven by infrastructure developed by Lagrange. So that's what I really kind of want to end with today. The future of crypto is zero knowledge. It is unquestionably a directionally correct technology, and the tools and the substrate that enable that not only will capture tremendous economic value, but they will augment and fundamentally alter how computation works and how applications are delivered across all of crypto and all of society in general. Thank you all so much.